All right, chapter 9, water and minerals. We are going to be dividing this chapter up into three parts. The first part, we're going to focus on water. The second part, we're going to be focusing on the major minerals. And then the third part, some of the minor minerals. So, not a huge chapter, but a good chapter where we can kind of chunk the material, as they say. And let's begin with water. Um, Water is essential for life, right? We have water, H2O, as one of the major, that is the universal solvent. It is able to dissolve and makes up the majority of the body. 50 to 75% of our body weight is water, with most of that being in the intracellular tissue. Water is not needed or no digestion is needed. It's easily absorbed. It is not an energy source, but it is essential for life. And because of its many, many, many functions, if you look at table 9.2 in your textbook, you will see that it acts as a solvent. It's the universal solvent. It's the relative chemical makeup and structural makeup of the hydrogen and oxygen make it very beneficial in the body as far as transporting ions and removing wastes and maintaining proper blood pH as far as transporting those ions. It is used as a lubricant within tissues. It is used to regulate body temperature. And we've spoken a lot about water as far as how it's involved in the physiological role of digestion, okay, your acid base balance and proper blood pH. It is also a major component of body fluids, your blood, your saliva, your sweat, tears, the synovial fluid within joints. So it has many numerous roles and functions and makes it quite unique and very essential. Why it's also unique is because of its properties as far as diffusion. Okay. When you have, or excuse me, water um, uh, is able to, or excuse me, simple diffusion occurs because of the properties of water. And you see here in this example, the red dye more concentrated here on the left-hand side of the container than on the right-hand side. Water will eventually cause these dye molecules to diffuse. It will move from where they're more concentrated to another, less concentrated. So diffusion through this simple diffusion process is one of the many benefits of water, the equilibrium. Another benefit here is osmosis. Osmosis is the diffusion of the solvent, okay, through these selective permeable membranes. Okay, water crosses and the solute doesn't. So water goes to that higher level of concentration, making this happy medium. Water moves from the one compartment that is less concentrated to the compartment that is higher concentrated. So, again, one of the many benefits of water that you see here. When we do not have water, or when we have very little or not enough water, that is referred to as dehydration or the body being depleted of water. And it can be and is a serious life-threatening condition. Can lead to hyperthermia, heat, stroke, okay, heat-related issues. The body shuts down. through, remember we talked about all the major functions of water, how it's involved in it's the solvent, removing waste, lubricating joints, body temperature. Okay. So when you don't have enough water, it can increase the risk of hypothermia and uh, hyperhidrosis, the profuse sweating in combination can lead to the life-threatening event, which we definitely do not want. When we look at water in the body, we see that the majority of water is what we call, well, there's two major fluid compartments in the body. Let's put it that way, intracellular and extracellular. Okay, the intracellular fluids inside the cells. The extracellular fluid surrounds the cells, which is your fluid tissue, or it's the watery fluid in the blood or the plasma. And water is exchanged between the plasma and the tissue fluid. Um, um, back and forth as you see here. Okay. Water, the majority of your intracellular fluid is within your cells. About 2/3 of your body water is inside the cells within these fluid compartments, and the extracellular fluid, known as the watery portion of the blood. And it's a fine balance. Okay. And also maintaining this fine balance, you see some of these common electrolytes. You see sodium, you see chloride, you see potassium, and phosphates, magnesiums, or magnesium. It's a fine balance here between this matrix, which makes water so essential and for it re-emphasizes all of the functions of water. Excuse me. Where do we find water? Well, water is we consume it, obviously, but not only in just liquid water, but also in the foods that we eat, and we also make a little bit. So let's go through each one. Water intake, the average water intake for an adult is about 2,500 milligrams a day. And through a small or through metabolic processes such as like cellular respiration and things like that, your body makes about a small amount, okay, only about 10% of what we need, or as you see here, about 200 milliliters a day, which is not nearly enough to function. So we get get water in the foods that we eat. Okay, some foods have a higher percentage water content than others, like lettuce is about 95% water, an apple is about 86% water, bread, 39% water by weight. Okay, so we do get water from the foods that we eat. But also, you see the majority of it here comes from the fluids that we drink. So the milk, the orange juices, the waters, the coffees, okay, those kind of things, the fluid products that we consume make up the bulk of our intake. The output of water is also varied, as you see here. We are more familiar with, yes, overall urine output, okay? And yes, you do have some water in your feces, but we also have what's called expired air, okay? The perspiration or the humidity in the air that we breathe out. You have your indispensable perspiration here, that perspiration that we're not aware of, okay? Like at night when you uh, uh, perspirate a little bit at night. That the simple water just escaping from the skin type thing. And then, of course, sweat on instances where the body temperature does rise and we have sweat. So the average healthy adult is going to output about 2,500 milligrams a day. So you see where it's a fine balancing act, and we need to maintain our water balance. And it gets hard to do that due to environmental factors. We have temperature, humidity, altitude, and we're not always healthy either, right? Or sometimes we're sick and we have fever or diarrhea or vomiting, and we exercise. And also, there are certain certain things that we eat, such as calcium, or caffeine and alcohol and things like that, that can increase our water output as diuretics, as we will see here in just a little bit. Also, your kidneys are integral in regulating your water. They are the major body regulator of the water content and the ions needed to control that water. So, proper hydration and that whole filtering process is integral in your kidneys. Also, remember that your kidneys are removing certain types of drugs and other types of metabolic wastes, and water is the main component in your urine. So when uh, when the body is dehydrated, kidney stones can form, as you see here. The kidneys are the major regulator, like I said, of water content, so they are integral in that process. If kidney crystals or kidney stones get large enough, they will block the urinary output, and they can lead to pain and oftentimes need to be removed. If you've ever had a kidney stone, you know it. They are not fun. And I mentioned earlier how here you can have certain foods and certain beverages, such as alcohol and caffeine, that acts as a diuretic, meaning they're going to increase your urine output. Okay, diuretics are any type of substances that increase your urinary output and can lead to dehydration if that intake does not equal the output. And you also have natural water conservation mechanisms that are hormone related that help your body protect against the dehydration. And this is your antidiuretic hormone, or your ADHs, that you see here. Your adrenal gland is also going to secrete aldosterone, which is an ADH here. You see here in the pituitary gland. All of this helps the body to hold on to water by different ways. Sometimes it'll help the body hold on to sodium, and where there is sodium, there's water, or it'll help the body hold on to water in general. So it's the effects of these antidiuretic hormones and aldosterone on the kidneys is your body's way of protecting itself from dehydration. So that whole fluid balance, water balance, is hormonal, it is urinary, and it is systemic. Okay. So these two hormones work in conjunction with the body water to conserve sodium and or to conserve water, whatever the body needs at that particular time. However, water toxicity can happen, and it does occur. Usually, water intoxication or water toxicity does occur when too much water is consumed in too little of a time, and the kidneys just do not have time to keep up, okay, or they have difficulty filtering the water from the blood in such a short amount of time. This excess water buildup in the blood dilutes the normal sodium concentration in the blood and can cause hyponatremia. And we'll talk later on specifically about when we do the major minerals in part 2, how sodium is integral in that process. So when you have too little of it, how it can be deadly. Healthy people rarely, though, drink enough water in this short enough amount of time to for the water to become toxic, but it is possible. You also have it can be, or excuse me, it can happen when the kidney's ability to excrete water normally does not happen. You have uh, endurance athletes, such as your cyclists and your triathletes and your marathon runners who consume large amounts of water at a time, may be at risk for water intoxication, because it's a fine balance between needing those electrolytes and everything too. That's where, I mean, this is where it gets into some of the high, excuse me, higher physiological aspects of water intoxication. But for the normal person, it's very hard to occur because we just don't drink quite that much in a short amount of time like that. All right. I want to kind of pause there, and in part two, we'll talk about major minerals, and then in part three, we'll talk about trace minerals because I want to give each mineral their due and not kind of rush through it. So let me know if you have any questions about water, and I will see you in part two.